All right, greetings, fellow grade 11s. It's Mr. Hlajayo here. Welcome to Back to Basics. Look, now we are going to be, trying and understanding our, 2D and 3D shapes, right? And we are going to understanding our sine rule, the cosine, and the area rule, right? Yes. So now this is basically a past paper of November, I think 2018. Yes. Now let's look at this one. Now say this is question 7. They say in the diagram you are having P. You are given angle P, which is this one here, angle P, which is 67 degrees, and you are having PQ, and your PQ, which is 3 meters, this one, and your RP, which is 9.2 centimeters also. They are all centimeters. Now they want you to determine the length of QR. Right now, let me give you some brief revision in terms of how do we then identify firstly which rule that we are going to apply in here. Let's start here from your sine rule. Remember that now if let's say you are given this let's say you are given this triangle, right? Let me draw this other line very nicely so that you can see. Now let's say you are given this as your triangle. Now, according to now your sine rule, firstly, how do we then use our sine rule? So now for us to use the sine rule, you need to have what? You need to at least have this angle here with the corresponding opposite side, and you must also have the angle here and probably the corresponding opposite side, which means at least you need to have what? You have one complete pair, one complete pair. And when I say one complete pair, which means you are having an angle here, and then you are having also the length of the side opposite. And then now the other one, you must at least have have one unknown of the pair. We have one unknown. So which means from here, in this one, let's say probably you must have, let's say maybe this angle in here, and then you don't have this side. Then now you can be in a position to use this sine rule, right? You can be in a position to use your sine rule. Whereas now, for you to use your your cosine rule. So now according to now our cosine rule, let's draw our nice triangle here so that we remind ourselves about our cosine rule. Remember that for our cosine rule, for you to use your cosine rule, now this one is different. So for you to use cosine rule, you must have an angle, and if you want, let's say, to calculate your side, you must have an angle and this side here, your side x here, and also your side y here. So which means for your cosine rule, you must always have what? You must have both sides. You must have the two sides. You must have two sides and an angle in between, right? So you must have your side x and your side y with your angle in between, right? Then you can be in a position to calculate for your side z. Let's say you are making this to be your side z, right? Now, however, now this is when you calculate what? This is when you calculate for the side. Now, let's say you want to calculate for the angle for your cosine rule for your side, which means now you need to have side what? You need to have side x, y, and z for you to apply your cosine rule in and then when you're having all these sides, now you can then calculate any angle that is given. Let's say you want you to calculate this, they want you to calculate that, or they want you to calculate that, right? Or they want you to calculate that. So this is going to be all the any of the angle. You can now calculate any of the angle, but the key issue here is that now you must have all the sides. So this is going to be the rule for your for your angle. And for your side, you must have what? You must have your two sides and your angle in between. Right? This is just a reminder so that you are in a position to remember how to apply, or rather which rule to apply, either your sine rule or your cosine rule. Now let's come back and see this one. Now, when you check this one, which part of rule, or which rule are you then going to apply here? I think by now you are, you are confidently telling me which rule you are going to apply. It is definitely going to be your what? It is definitely going to be your cosine rule, because look, you are given the side, your side, and the angle in between, and they want you to calculate what? The opposite side here. So which means you're going to use your cosine rule. And look, your cosine rule here, it's going to be your QR squared. This is going to be your QR squared, which is the sides that you are given, and the side that you are given your PR squared plus your PQ squared, subtract your 2PR. This is going to be your 2PR multiplied by your PQ cos of what? Cos of this side, and the cos, this is going to be cos of what? Your angle P. Right, this is going to be cos of angle P. Then you come in here and then we substitute. Now, what is your PR? Your PR, you are given that this is 3 squared plus what is your PQ? Your PQ, it is going to be 9.2 squared. Subtract your 2 into, this is going to be multiplied by 3 multiplied by 9.2. Cos of what is the angle that you're given there? It's 7 degrees. But look, what is it that you are looking for? Are you looking for your QR squared? Remember, this is your QR squared. Are you looking for QR squared? No, the question required you to calculate for your QR, not your QR squared, which means basically your QR is going to be what? You're going to write all of these under the root, because you are looking for what? For this, the QR, not your QR squared. So this is still going to be 3 squared plus your 9.2 squared, subtract your 2 into 3 multiplied by 9.2, cos of 67 degrees. And the answer that you are going to have now for your QR, it is going to be what? It is going to be 8.49 centimeters, right? So which means this distance here, it's going to be 4.49 centimeters altogether. Then now you have successfully calculated that, right? Now let's see, let's try and make up some space and see what is it that we can do in our 7.2 now in 7.2, let's make up some space here, so that we write our 7.2 nicely here. Now, what is our 7.2 requiring us to do? Now, look, 7.2, they are saying now you are given that you are having this, which is your DCB, and what is your DCB? Which is your alpha. Your DCB is this side, right? Let me just try and use our color, even though this color almost matches the color of this font, right? So basically, this is the angle alpha that you are given. This is the angle alpha that you are given there. And you are given that your AC, your side AC, it is given by H, which is this one. You are given that your ACB, it is given by your beta, which is the totality of this side. Your beta, it is the totality of this side. Your AC, remember it's A, C, and this is B. Okay. Now, the first thing that they want us to do, they want us to basically find out what is going to be your what? They want us to determine the size of ACD. So this is ACD. So they want us to, determine the side of this angle, right? So this angle basically, let me try and get another nice color there so that you see which part of which angle that you have. This one, yes, you see, yes, this one that I'm highlighting with your light blue. So they want us to find out what is going to be the size in what? In terms of theta, subtract your beta, right? In terms of theta, subtract, or rather in terms of theta and your beta. Why am I thinking of subtraction? Look, now what is it that we are going to do? Let me just give you this narration. Now, if let's say, for argument's sake, let's say for argument's sake, you are given that your angle theta, right? Let's say you are given the value. They said your angle theta, let's say your angle theta, that is given by your 70 degrees. It was given by your 70 degrees. And let's say your alpha, it is given by, let's say, your 30 degrees. right? So for you to find out this angle ACD, let me erase here so that you can see what I'm referring to, right? So now, for you to calculate, now we are saying this angle here, it is given by 30. This one is given by 70. This is just an example, right? Now, isn't it that for you to find out what was going to be your angle ACD, you were going to say, look, this was going to be same as 70 degrees subtract 30 degrees, which is this totality subtract the small one, so that you get this angle here. And the answer that you're going to find, this was going to be 40 degrees, right? This is what you are going to do. Now, similarly now, let's say now your theta and your alpha, you're considering them to be these values. So which means now in your 7.2.1, 7.2.1, now your angle ACD now, your angle ACD, it is going to be what? The theta. Got this theta as your 70, which means you are going to say now this was going to be your theta subtract what? This is going to be theta subtract your what? Subtract your alpha, because even here, if you're given the values, it was going to be 70 subtract your theta, right? So which means basically your angle ACD, it is going to be given as your theta subtract your alpha. Then you are absolutely now correct, and you are done with your 1 mark in there. Isn't it so? Then now let's look at 7.2.2. I know, most of you tend to, look at this and you look at this and you think, this is too much for me. I cannot do it. But look, now I'm just going to give you the secret recipe of this. Let's start here. Now, so they want you to determine what is going to be your AD. Right? And now let's come in here. I always like to, every time whenever I get something, I come and substitute. We already found out that this is the angle here, it's theta subtract alpha. That's what we've already found out about your angle ACD. All right? Now, what is it that you are going to do? So now we are going to look for your AD. And now for us to look for our AD, look, it is almost impossible to apply any of the rules, because I mean, look, if let's say we wanted to apply your sine rule, now for you to have your sine rule, you must have this angle, the side here, and at least because we have the side in here, you must have this side also here, right? So which means now if we can find out what is your side, or rather your angle D1, then we can be in a position to calculate or to find out what is going to be this side. So now let's see in terms of what is it that we can do. Now, if I can take this angle here, let me just try and draw this small triangle in here. Now, this is how your angle, let me just try and copy this. This is your C, this is your B, and this is your D, right? And your D1 is here, right? Now, if I want to find your D1, can you see that your angle D1, it is going to be the exterior angle of your triangle, right? Remember your triangle DCB, right? Which means your angle D1 is going to be same as this plus what? This plus this, because I remember according to our exterior angle rule, it states that now the exterior angle of your triangle is equals to the interior opposite angles, or rather it is equals to the sum, not just the interior, but it's equals to the sum of the interior opposite angles. Let's say for argument's sake, now let's say this it is given by 30 degrees and this one is given by your 90 degrees as it is given here. So which means your angle D1, it was going to be what? 30 degrees plus 90 degrees, right? And 30 plus 90, it's 120 degrees, right? And this is just, the theoretical perspective or side of it. Now, if you are agreeing with me as your D1, so which means you'll also agree with me if I can say now, firstly, now in my 7.2.2, I can start by finding my D1. my angle D1 in this regard now, because look, your angle B, yes, it's 90, but this angle here, it is not given by 30 as I did as my example, but it's given by your alpha, right? So which means my angle D1, it's going to be same as what? It is going to be same as 90 degrees plus my alpha, right? And now, the simplest reason that you can write there, this is going to be the exterior angle. This is going to be the exterior angle of your triangle, right? This is going to be your exterior angle of your triangle. You can even state what triangle that you are referring to. This triangle, it is triangle what? This is triangle DCB. DCB, right? So that we know what is it that you are referring to. Right now we have our D1, and remember the example that I did, that for me to be in a position to apply at least any of the rule, and the rule that was at least closer here, it was what? It was your sine rule. Remember that your sine rule require you to have this angle here and the opposite side, and this angle here and the side that is opposite, or the angle here and the side that is opposite, vice versa, right? So, and remember when I started that, I said for you to do your cosine rule, you need a complete pair and a half pair. So which means now we are going to say, look, now we are going to apply the sine rule. And then we are going to say, look, now, because we are looking for side 80, right? Isn't it that we are looking for side 80? This is what we are going to do. We are going to say, look, now 80. Now 80, this is going to be the side. It's going to be the side. Remember, according to sine rule, remember that sine rule, if you are looking for the angle, it's going to be your A over your sine of A, which is equals to, let's say, your B over your sine of B, right? Whenever we are looking for the side. And in this case, now we are looking for the side. So I always prefer that I write my side that I'm looking for in my numerator. So if I'm looking for my side 80, this is going to be the 80 over now your sine of what is the corresponding angle for the 80. It is what? It is same as your what it is given by your theta subtract your alpha. Remember, we've calculated, or we found it as your theta subtract your alpha. This is going to be, now, do we have another complete pair? Yes, we have H, and also that corresponds with your angle D1 that you've already calculated, which means we are going to say, look, now, this is going to be H over what? This is going to be H over sine of what? Now, what we found as our D1, the D1, we found it to be what? This is going to be your what? This is 90 degrees plus your alpha, right? So this is going to be that. And now, what is it now that we can do from here? So the simplest thing that we can do from here is, now we can now cross multiply, because look, we are not looking for 80 over sine theta over alpha. That's definitely something that we are not looking for, but we are looking for 80. So if you are making 80 the subject of the formula, we are going to say, look, the 80 is going to be, now we are going to multiply this one in here, the 80 on the side, right? So which means we are going to say this is going to be H over, now this is going to be H into theta, subtract your alpha, divide by now sine of 90 degrees plus your alpha. And now remember, this is your reduction, right? Remember that we have your reduction, right? And according to the reduction, remember when, let's say, for argument's sake, let's say you have sine of 90 degrees plus your theta, right? Plus your theta. We know that now, because 90 degrees plus your theta is in your second quadrant, right? It is in your second quadrant. And what is your sine in your second quadrant? Remember, from here it is all student take coffee, right? And in your second quadrant, your sine is positive, which means now this is going to be same as what? Also, this is going to be the cos of your theta. Now, similarly here, now this is going to be same as what? Now, if you are changing this, this is going to be same as your 80, which is going to be H sine of theta theta, subtract your alpha over, now this sine of 90 degrees plus your alpha, it's going to be same as your what? This is going to be same as your cos of your what? Cos of your alpha. And therefore you have successfully, proven, or rather you have successfully answered your question 7.2.2. You have proven what they required you to prove, right? Thank you very much. Now let's look at now our 7.3.2. Now look, in question 7.2.3, I mean, right? Look at this two. Yeah, right. Now let's see. Now they say determine the length now of 18. If h is given by 17 units, theta it's 58 degrees, and your alpha is 23 degrees. Look, I always say this to my learners that look, every time, whenever you at least in a position that you cannot prove this 80, which I'm not condoning that you are not in a position to prove, but let's say due to some time constraints you are unable to do that, at least now you must come in here and say, now you are already given what is your age, what is your theta, and what is your alpha. So you can come back and say, look, this is my 80, which is going to be equals to, now you substitute all these things that you're given. They are saying, what is your age? Now in a space for age that we are going to write, this is going to be 17 sine of, now what is the theta? It is 58 degrees. Subtract what is the alpha? It is 23 degrees. This is going to be divided by the cos of what? Cos of what is the alpha there that you are given? The alpha that you are given, it's 23. So let's write it nicely here. This is going to be your 23 degrees. And you plug this thing in your calculator, you will easily find your answer of your 80, which is going to be 10.59 what? Units. Remember, are you given in terms of what are the units there? No, so you're going to write this in terms of units, right? So you've already found out what is going to be your 80, isn't it so? Now let's look at the last question. Now they want us to calculate what is going to be the area of ADC. ADC. Let me come and, remove all these things in this diagram of mine. Look, now, what is it that they want us to do? They want us to calculate what is your ADC. So ADC, it's this one, ADC, right? This is the triangle ADC. Now, how are we then going to calculate for the area here? Let's start here. Remember that they are, this is 7.2.4 area. Now, area, it is given by what? Now, for you to have your area, now you always apply the same rule. You always apply the same rule as your cosine rule. Now, let's say now you want to find the area of any triangle. For you to find the area of any triangle, you must at least have your side X, your side Y, and the angle in between, right? This is also for your what? This is for your area rule. So this is basically the fundamentals of your area rule. You must have your side side Y, your side X, and your angle in between. So now let's see. Now, yes, indeed, we are given that your side H, it is given by 17. Your AD, it is given by what? Your side AD, it is given by what? It is given by the 10.59 that we've just recently calculated. So now, and what else now do we have in here? Let's see in terms of what else do we have. So look, already now we've calculated all the angles. Now your angle D, remember your angle D1. Your angle D1, it was given by what? Theta subtract your alpha. And what is the theta? Remember your theta that you are given, it is 58. 58 subtract your 23, right? 58 subtract your 23. And now what is it that you are going to get? Now you are going to find out that now your angle in here, I think, look, when you say 58 subtract your 23, this is going to be, then this is same as, let's see, this is 30. Now this is going to be when you say 20. Now when you say 50 subtract 2, this is 50 subtract 20, it's going to be 3, and then 8. Now subtract 3, this is 5. So this is going to be a 35, right? Now this is going to be a 35. And now what else can you have? Now, you don't even need that. Look, you only need this from this bigger triangle. Now, the only thing that you're going to need, because you're having this side and you're having this side, so which means the angle in between that you need to have, it's your angle A. So, there's no need of us to even calculate for this triangle. You can just calculate for your triangle A, BC. And your theta there, you are given that it is what? It is 58. So here it is 58 degrees. It is 90 degrees, which means your angle A, firstly, your angle A, it is going to be given by 32 degrees. And now that you have your 32 degrees here, now you can be in a position now to find out what is going to be your area, because you have this side here, you have this side here, you have the angle in between. So now you're going to say, look, my area, the area of triangle, what? Of triangle ADC, is triangle ADC. It is going to be given, and remember the area formula, it's half multiplied by, now the side over there, it is what? It is your AD, it is your AD multiplied by your AC, sine of what? Sine of angle A that we've just recently calculated. So let's come and plug this. This is 1/2 multiplied by, what is your AD? Now your AD, it's 10.59 multiplied by, what is your AC? Your AC, it is going to be given by 17. Sine of, what is the angle that you are given there? Your angle A, it's 32 degrees. Then when you plug this in your calculator, what is it that you are going to have? This is going to be 47.70. And do you have the units? No. So this is going to be units. And remember, area, it is always measured in what? In squared. Then you are done. You see, you are done. You've taken your 13 marks. Then you are happy. You've passed your exam in flying colors, right? So thank you very much, good people. Thank you.